Chapter 13 has to do with the trade-off between risk and return. And finance is very much driven by two major factors: cash flows and risk. So in this case, we're going to calculate the risk-return trade-off between, you all know the basic principle. The higher the risk, the higher the rate of return. So you can see in this basic graph here, the higher the level of risk, the higher the expected rate of return. Very simple trade-off. It would be a bad investment to have high risk and low return. Just like non-business people know that. So if you want if you can find something that's low risk, high return, let me know, because I want to invest in it also. Doesn't tend to happen. So low risk, low return, high risk, high return. And we're actually going to do a calculation on the risk return trade-off. And it's based on the probabilities, a probability distribution. The wider the probability distribution, the more the risk. So from stats class, remember a concept called standard deviation? That is how we measure risk in finance. The higher the standard deviation, the higher the risk. The wider the dispersion or the distribution of the numbers, the more risk there is, the more variability there is. The low risk is very stable. So a company that has earnings per share of 1 year of $0 and next year of $4 is much higher risk than a company that in year one, their earnings per share is $2 and the year two is $2. So they both average to be $2, but the 0 and the 4 is a higher risk than the 2 and the 2. Like, okay, what's the earnings per share for year three? For the company that's 0 and 4, you say, well, it's going to be between $0 and $4. For the company that's 2 and 2, say it's probably going to be $2. So you know what you're getting. So we're going to do some calculations here where you're given the probabilities of the outcomes. So you have pessimistic, moderately successful, and optimistic. You're going to calculate the expected value, which is simply take the values and multiply them by the weights. We'll calculate the standard deviation and something called coefficient of variation. So in this case, to find the expected value, you simply take the D, which is the demand, multiply it by the probability, and then sum them up. So the expected value, or the weighted average value, is $600. You plug it into the formula, which is at the top, formula 13.2 at the top of your screen, and you go through the calculations. And we'll do this in class when I go through the examples. So this simply takes, you find the D bar, you take the demand, subtract D bar. D bar is the average, by the way. You then square that number, and then multiply it by the probability, and then total it up. And finally, you take the square root. And that will give you the standard deviation. So all of this is done to calculate the standard deviation of $190. So you have an average of $600, and you have a standard deviation of 190. So you would be familiar with that from statistics class, where you have a mean and a standard deviation. That's what this does. So you can see that, and we'll go through these several of these examples from the book. You can see that the V, the coefficient of variation, which is where you take the standard deviation and you divide it by the return. You can see in the top left-hand corner, you have a much narrower distribution. The bottom left-hand corner, it's flatter or wider, and the V goes, in this particular case, to 3.17 or 0.317, and the first one is 0.033. So the 0.033 is the risk-return trade-off. And finally, in the bottom right-hand corner, you see a very flat distribution. The reason for that is you still have the same D-bar, but you have a much higher risk. So in this particular case, of the three, I'm going to invest in the top left-hand corner. So the bottom line is you want the lowest coefficient of variation, which is the V value. So what this does is it factors in risk and return. The numerator is risk, which is measured by standard deviation. The denominator is return, which is D-bar. In all three cases, D-bar stays the same. You're going to get an average return of $600. Would you rather have 20 units of risk, 190 units of risk, or 300 units of risk? You want the lowest risk relative to the same return. And when you have different numbers, you just look at V, coefficient of variation. So even if it wasn't the same D-bar, you simply look for V. And the lower the V, the better trade-off. So you have two returns. All right. And in one case, you can increase your return by 10%. So the $1,000 return becomes $1,100. Sounds like a good deal. But you have to accept the higher level of risk. Now, if your risk only goes up by 5% and your return goes up by 10%, that's a good deal because your return is increasing faster than your risk. Now, if you can get a 10% increase in your return, but it requires a 25% increase to risk, that's a bad idea. So your return goes up 10%, your risk goes up 25%, you're worse off, even though your return went up. So you can't measure it just on return, which is quite often measured by net income. You have to look at how much extra risk did you have to accept. So finally, if your return goes up by 10% and your risk goes up by 10%, you didn't gain and you didn't lose. You're not better nor are you worse off. And every corporation has a risk profile, just like every student or every person in the world has a risk profile. Some people are risk averse. All they look at is risk. I just want to keep my risk down, keep my risk down. Other people are risk neutral, and other people are risk seekers. If you see a show on TV where the person is into extreme sports that are very dangerous, that would be a risk seeker. So each one of you has a risk profile, whether you realized it or not. So here's the calculations. In this case, the numbers have changed. And you simply look at V. I'm going to invest in A. B is a worse option because it has a higher coefficient of variation. Option A is better because V is lower. And there's the formula, 13.3. Risk divided by return. Standard deviation divided by, and that should actually be D-bar, average demand. Now, beta, what beta does is it's used for stocks and compares an individual stock to how risky the market is. And you can see in this particular case, how you would interpret this, Bombardier has a beta of 1.17. What that means is if the stock market changes by 1%, Bombardier's share price will change by 1.17%. So if the stock market goes up, Bombardier gains 17% faster than the average. If the stock market goes down, Bombardier loses 17% faster. So that's an above average risk. Power Corporation and Royal Bank are almost exactly one. So they go up and down. If the stock market goes up by 4%, Power Corporation will basically go up by 4%. Stock market goes down by 7%, Power Corporation and Royal Bank will basically, their share price will go down by 7%. If you see the beta where it's quite low, like Canadian Tire, so if the stock market goes up by 1%, Canadian Tire's share price will only go up by 0.33. Sorry, 23. If, again, the stock market goes down by 1%, Canadian Tire shares will only go down by 0.23. And so what that means is Canadian Tire shares are very stable, very relative to the average. They're much less risky. So the least risky on the sheet is Canadian Tire. The highest level of risk is Teck Corporation with a beta of 3.89. So it tells you if you're above or below what happens with the stock market. If your share price is going to go up faster or go down faster, that's higher level of risk. If your prices go up, share price goes up at a slower rate or goes down at a slower rate, that is less risk. So the higher the beta, the more the risk. The lower the beta, the less the risk. And that's the end of chapter 13.